Andreas, I got it. So Andreas, it seems, do you see any technicians? So should
they're in the back there.
So I should be around with the microphone, I guess.
Yeah, I'm not sure whether they do that, but you can keep it. I'll keep it. Okay. So good morning, everyone. So my name is Andreas Wallraff. Just for those who don't know me, I'm a professor at ETH Zurich. I work on superconducting circuits, and I'm part of one of the flagship projects that have been funded in the quantum computing pillar. Together with Fabio Schiarino and Jordanis Kyrienides, we'll moderate this session on quantum computing today. Okay, so you from yesterday you know roughly where we are. So the EU has selected 5 quantum computing projects out of the submissions. 2 of those quantum computing projects are in the quantum computing pillar. So there's one on ions, which is called Action, and one on superconducting circuits, which is called Open SuperQ. And the EU has also selected 3 additional projects in the basic science section. One of them is on ions. It's micro-QC. There's another one on superconducting circuits, QMix, and one on rare earth ions, Square. And as Rob said today, I think the goal for this meeting is to actually get ready for the first 3 years of this quantum flagship and in the quantum computing pillar, and also prepare for the next phase of the flagship by understanding what maybe went well in this round of the project allocations, and what would we need to do for launching successfully the next round of the project. And obviously I also recently, after being happy about having received some of the resources from this pod, we noticed that, okay, good, there's only 2 years left until you probably have to apply for the next round of flagship calls, yeah? And maybe for some of you that might be even earlier. So it's already time again to think about how to move on. So the goal for today will be to collect your input for how to actually run the flagship in this first 3 years and how to move beyond that. And it will mostly not be us saying things, but us trying to moderate input that you may have. And in the end, this will be compiled into the strategic research agenda. That will be, the quantum computing part will probably be a 10-page document there. And so what I do think is that we'll probably structure the responses that we have, or the questions that you may ask, or the input that you have in 2 different directions. So one of them may be structural questions, yeah, on how the flagship is organized now and how it might be organized in the future. And then also technical questions, what do we really need to succeed in building a European quantum computer? So that's roughly how I see it. And so for today, how we'd like to structure this session, and also the other 4 sessions that you could be, the other 3 sessions that you could be attending today, is they start out, okay, the laser might not work. So they start out with a little discussion of where we are, which I gave to you already. So by mentioning the funded projects, then we'll have a discussion about what is the vision for the project within a 3-year time frame, and then what is the vision in the time frame beyond that, so 3 to 10 years. And I would say, like maybe you might find some of this division a little bit artificial, in the sense that obviously we're all ambitious. We want to build this quantum computer, and we probably want to do most of these things as early as we can. But maybe there are some more important in this first 3-year time scale than others, and that we should probably try to identify which ones these are. And there is a sort of a rough division, 15 minutes and 20 minutes for this sort of more shorter term goals, and for the longer term goals. And then at the end we should also focus on on these cross-cutting technological challenges that might also connect the quantum computing pillar and all the quantum computing activities to the ones in the other pillars, and identify common challenges that we can maybe address better together by joining forces and by knowing what we want. Okay, so where are we? I've mentioned it to you already, and so I think we should figure out what our main questions are for our main inputs are from the community, so from us and everybody in this room, to structure this discussion today. And we'll take notes of your inputs, and if you should also maybe make some notes, and at the end, if you want to relay this information to us, just feel free to send any of us an email or contact us also after the session. Okay, so I think with that's probably enough for the introduction, and then Fabio will arrange the discussion of, okay, what is the plan in the next, or what could be the challenges in the next 3 years, what are structural challenges and what are technical challenges, and we'll walk around with the microphones, collect your inputs, and maybe one of the thoughts that we could follow, if somebody picks up a topic area in this discussion, maybe other people who have a similar question in mind or want to add something to what was said, we should give maybe a priority in who talks next, so that we can structure a bit the inputs that we have from different people. So if you go first, you can set one of the topics. And so with that, I'd hand to Fabio to continue the discussion.
Okay. So I would start then from, we should now start discussing where we are. So we should spend 5 minutes on that topics. So we already discussed the projects that have been funded. Maybe we could briefly comment on what we believe is missing on that point. So maybe we should organize with the microphone.
Okay, so Enrique Solano. So maybe I should also remind you, maybe you can just, in case that everybody gets to know everybody else, to briefly mention your name and your affiliation.
Thanks. Enrique Solano, University of the Basque Country, Bilbao, and Shanghai University in China. My first comment is related to the, of course, the non-strategic decisions of the flagship, because yesterday we heard that there was no strategic decision, which is weird, just to say that. This is not an issue of being democratic, friendly, or we have to engage and we have to make decisions. This is one thing. And in that, the consequence of this lack of global strategy for the choice of the winning projects has led to something that I find incorrect, in principle related to quantum computing, the fact that mostly quantum computing paradigms that are purely digital, sometimes with error correction or without, have been funded, and others have been let aside, and I find it not correct. I can mention coherent quantum annealing. I can also mention one-way quantum computing. I could mention neuromorphic quantum computing, or many other aspects. And for example, I was discussing with colleagues that were involved in the decisions, and for me it is not clear who decided and why that, for example, quantum annealers or coherent quantum annealers belong to quantum simulation or to quantum computing. And each time, as we know in Brussels, where you have this uncertainty, whatever you apply, it can be brilliant. Nobody wants to say, oh, I choose this or I choose that, and suddenly we are what we are. And I think that for the first session, for the first round of projects that have won, we have to, we are obliged to give the opportunity to alternative paradigms of quantum computing to fail, if you want. But we cannot expect that in US or in China, suddenly, for example, quantum annealers start to be good, and we start here in the flagship in the 5th year, where it is a little too late. So that's more or less my comment.
Thank you, Enrique, for the feedback. We have then Philip, and then
so let's try to pick up questions that relate to this strategic aspect, if you can.
So my name is Philip Walter. I'm from the University of Vienna, working on optical quantum computers. Basically, I want to follow up with what you said. So it's of course important to put an emphasis on leading technologies as it's currently happening, and that's the part of the flagship program. However, we should keep in mind there are other architectures and systems where Europe is very strong. So, of course, I could talk about myself, optics, but there are other systems as well, like semiconductors and so on. But I think at this early stage, it's important to keep basically redundancy or some parallel methods and architectures in mind, because otherwise we might narrow down too much at the end and might overlook other systems that are at the end will turn into some very interesting, promising directions. Okay. With that, I just can basically agree with what you said, and that's an important thing here in the early stage to not lose track of alternative routes for computers. That's it.
Hello, my name is Harry Berman. I work for the University of Amsterdam, and also I'm director of QSoft, the Research Center for Quantum Software. And what I think is missing, especially in the computing pillar, and projects is, of course, more software and a dedicated project for finding use cases and for finding algorithms. And as Thierry Breton, yesterday CEO of Ethos, eloquently made clear, we are missing that at the moment. And a healthy industry for quantum computing has three equally important components as in classical computing, and that is, of course, quantum hardware. But equally important is quantum software, and the third component are the users. And number 2 and 3 are currently missing. And I think it's important that that situation is fixed.
Okay, so maybe we'll take 2 more, and then I have maybe a comment. Maybe the lady first.
I want to continue this. So Laure Lebas, SAP. I'm working for SAP Research and interested in looking at this quantum software. So I'm looking on the business application. So when we talk about software, it's not this layers that are making sure the hardware is working, which we need to do. And I think, my point of view is that we have to trust whoever is doing the hardware, that they do a good hardware, but we have to understand which way it's working, and we have to prepare it. So this, to put, in addition to what Harry said, the industry point of view, we would like to work today on what will be the use cases that will make sense, that will really benefit from this, and starting to work on it from the algorithmic point of view, to make sure we are ready and we benefit from it when the hardware is ready. And more importantly, if we talk about enterprise application, Europe is leading on this, sorry to say, but SAP is #1 worldwide when we talk on this enterprise application, and we are European. So let's benefit on this. We have this advantage in terms of, we talk about artificial intelligence, etc., which are probably use cases as well. So that's what is missing, and that's what we would like to we don't want to wait another 3 years for next program or something like this.
Thank you.
So John Morton at UCL. So I think I'd like to agree with all the previous comments and just briefly comment on what's been happening in the UK. We've had our own sort of mini type of flagship with first rounds of proposals already evaluated 4 years ago. And it followed a similar kind of process with individual projects assessed, and the results were what they were. And right now there's a second phase of the program that was formally announced yesterday by the Chancellor, but the planning has already been going on. And what's clear here is it's much more of a managed process. So the leadership for the whole program has decided, for example, in computing, we need software, we need applications, we need these particular strategic platforms, and that has helped really set the agenda for how the whole program is put together. So I think it is possible to, or I think it's indeed important to have that kind of strategy. Otherwise, you're essentially outsourcing the strategy to what can be a stochastic process.
All right, good. So maybe I'll ask a provocative question a little bit, try to stir you up. So there's a question about what other approaches should be researched, what other hardware platforms should be looked at, how much more software do we need? Yeah? So there was a limited budget in the first round, and we all know that building quantum computers is very, very challenging. So how would we like to do it? Would we have divided up the budget to even smaller chunks and maybe risk that we won't build any quantum computer with that budget, or is what we need to tell the EU, okay, they will, what I heard in terms of inputs all sounded like very relevant inputs, but it would probably mean that we would need to triple the budget or so in the quantum computing pillar to address all of those. So maybe you have some thoughts about it. Should we cut down the budgets into smaller chunks, or do we just need to lobby for more resources to make this happen? So any thoughts on that? So there's a person in the back and also.
Paolo Bianco, Airbus. I'm one of the potential users of quantum computers. Something that I've always been very keen on was to make sure that this process also addresses what others are doing outside the quantum flagship. Over there I see 50 qubits in 3 years from now. Yeah? Do we benchmark ourselves with respect to what is happening in the rest of the world? Do we need to take any action with respect to that? What could these 50 qubits be useful for final users like myself or the company that I represent? This is something important because then it's going to drive the research, I think. Thank you.
Thank you, Paolo. So we propose that there was a question by Marcus Aspelmeier. Then we can move to the next subject, which is what we are going to do in the next 3 years, so to answer these kind of questions.
Okay, so Marcus Aspelmeier from the University of Vienna. I'm not directly working in the field of quantum computing and would like to react respond directly to Andreas's provocative question with a possible answer. So one of the ideas, I guess, of having a strategic research agenda and involving strategy would be that our community can make a clear suggestion to the Commission based on our ideas and opinion where the strategy should go. And if the strategy involves other platforms, then a strategic recommendation of this platform here to the Commission could be to add additional resources for these other platforms. And as I understand from yesterday, this has already been taking place, at least for the case of solid-state computing.
We have one further question on the right side from Buram.
Any other thoughts about how to address the resource question? Is it more lobbying?
Yeah, of course, more money is always good. So we should certainly keep on lobbying, and I think that's happening at the moment. But with respect to the missing part of quantum software and quantum algorithms and use cases, luckily those are much cheaper to fund than funding quantum computing hardware research. So with a little bit of additional money, or maybe a little bit of cutting down what's there and funneling it to quantum algorithms, quantum software project, you would already remedy the situation a lot. So cutting down a little bit and keep on trying to get more money. That's my suggestion to Andreas's provocative question.
So I would propose I start doing the next questions, because otherwise we stuck on this part. So we already had the feedback on the alternative models to exploit the strength of Europe about the software, the end user case, and what we're going to do in the next 3 years. So we can move now to the first challenges of the quantum flagship. We already started addressing what is missing, and now the main question is what are the challenges that we're going to address in the first 3 years. In particular, in the last few years we have seen how noisy intermediate scale quantum technology is attracting a growing interest. That's the framework to hope to achieve quantum supremacy, and so I guess that's now time to start to discuss that point.
Anybody?
Yeah, my name is Jürgen Stuhler. I'm from Toptica Photonics. I'm sorry, but I do not really understand the first question, because you are asking what are the challenges that we are going to address in the first 3 years, and I thought that's already been decided because the project are already funded. they should know what they want to address? Is this wrong?
I reformulate the question. So we know what has been funded. Should we add something more on that for the next 2 years? So this is connected to what we discussed before. So before it was a larger perspective. We know what has been funded. It's not the overall picture. So what are the key ingredients that you believe as community we should add? I hope I corrected. Okay, I guess now more question, which means. So may I have the microphone that everyone can.
Juliana Radu, IMEC. You mentioned that there are mechanisms to add things. What are those?
So now what we, as Rob anticipated before, the strategic research agenda will be ready within the next July. And this will be then shared with the community and with the European Commission. Already yesterday we heard that there will be a new call on quantum computing for semiconductor. So our goal is to have a kind of document that can be exploited then on the higher level, eventually to have some kind of pushing in some directions. I don't know if Andreas wants to add something on that point.
And maybe we could collect some more inputs from other people who haven't spoken yet on that question, how to add things. So there's Mikko Muttinen.
Yeah, Mikko from Aalto University of Finland. About the challenges, I think now, I think the selection panel has made a very good job on selecting the projects. And well, of course, I also agree with other people that, some things like the coherent annealer is definitely missing. And we need user cases to show that we can attract the interest of the industry. However, now I think that there are also, it has been already pointed out yesterday that a lot of good proposals have not been funded. And what I think is that now the challenge is that to think that, for the funded projects, for this, the major pillar projects, how those could now take advantage of the groups that were left out in this first selection round, how to increase the collaboration and how to involve, the full capacity of Europe in building a quantum computer. I think that is a major challenge. It has a lot of things related to IP, for example, and a lot of things related to trust. And I think these issues should be solved so that the Europe, not only the few selected groups that are now in the projects, but Europe as a whole could, take on this challenge together.
Okay, I just wanted. Shai Machnes at Saarland. I think that, for example, every project that tries to build a quantum computer has to deal with certain issues that are kind of across the board, such as control, software stack, etc., etc. But we haven't built into the structure of the flagship cross-pollination between the various projects. And I think there's a lot of stuff that's worth discussing that's basically why to any project that's trying to build a quantum processor. So we need to kind of structure sharing information between the various projects.
I can add a comment on that. So we will have, at the end of the discussion, we will discuss the cross-cutting areas. This will be discussed in another session, and then all this information will be then discussed together after the lunch break. So that's a good time after to provide input, and then to see whether all the different application areas share some common part that we should address all together.
Is there anybody who has any additional thoughts along the lines of Mikko Muttinen and what to do to integrate Europe better among the existing activities, which are not all currently funded in the flagship? So I think that's an interesting question that we could suggest something to that would actually work still in the first 3 years of it and could make a difference, if you have any thoughts about that.
Just a talk. Yes, hello, my name is Simon Theising and I'm from the European Patent Office. And my question is after 3 years, so we heard some business use cases and so on, but have you developed a strategy on protecting your ideas? Or is it not part of these first 3 years?
So maybe we defer the IP question for just a second, and maybe the gentleman here in the front, he wanted to say something about in the line that Nico Myrtinen had talked about.
I'm Martin Leijman from School of Informatics, Charles University Prague. I think what is missing is to build more bridges with the informatics community.
Okay, some other input.
I'm Ross Duncan from Cambridge Quantum Computing at the University of Strathclyde. Just to respond to Miko's suggestion, in the flagship we have a small number of very large projects. For application development, especially on the software side, it might be more interesting to do smaller, shorter projects with lesser budget.
One question on the left side and one on the back.
Hi, I am Jonas Bylander from Chalmers University. I work on superconducting quantum computers with Andreas Wallraff and others. I think the actual biggest challenge is to build this machine. Use cases are good for some direction, but we need engineering to do software and hardware and different things. So, I mean, it's easy to promise big results, but I think the real challenge is on the engineering.
Nadav Katz, Hebrew University, Israel.
My name is Floor van der Pavert. I'm from QSoft in the Netherlands. If there are no applications, why bother building the machine anyway? But if you look at the quantum algorithms that are currently available, I'm not convinced that that is interesting enough, like commercially, to put so much money in building that computer. But there is so much more out there that we don't know yet on the algorithm side. And it's too late if you wait until the computers are built.
So we had a question from the back which was waiting, and then we can go to the other three.
My name is Nadav Katz from Hebrew University in Israel. I want to agree with the comment about engineering and specifically manpower. I think we're going to run into a bottleneck of critical manpower in microwave engineering and laser photonics or cryogenic amplification very, very quickly. And this manpower deficit needs to be addressed, I think, much faster. Maybe crash courses integrating classical industries. I think we need this now and not in another 3 years to ramp up.
Could you repeat your name, please?
Nadav Katz from the Hebrew University in Israel.
Thank you.
Good morning. My name is Łukasz. I am from Poland, from Bait Company. I completely agree with that gentleman. We are a 7-people startup with some successes already. We are mostly mathematicians and software developers, and we don't need millions of money. We rather need a support like a grant to D-Wave and to Rigetti. For us, that's all. And what I would like to emphasize that such small companies are not visible on the market, although they don't have a huge requirements. Thank you.
Thanks. So we had one question on the back again, and then here. Then you.
Can I? Oh, yes. So Stefan from Rasen Research Center, Jülich. So look the example. We have this neuromorphic computing stuff as a good example back to us in the Human Brain Project. And what happened there, coming to the software topic? The hardware is not really fulfilling the requirements because the software stack was not early enough approached. Yeah? The mappings and all these things. We need to cover the whole stack when we start now to go in this direction, because quantum computing, I think, is even more challenging from the algorithm side and from the software stack side. So to cover this whole thing, need to fulfill everything, but also need to involve engineering in a certain correct way, because even that is on a really, really early research level. There's nothing clear on control, there's nothing clear on readout, because all the things you do at the moment cannot be just copied into a complete system, because if you have now thousands of qubits, you cannot just do it in this way as we do it today. That's not possible.
Yeah, so maybe I'll have a comment. I think there's really no question between software and hardware. I think we're all aware of the fact that for building a real quantum computer, it needs to address all of these levels equally and to make it work. So I think that is something that I would think there is a good agreement on in the community. The question is more how do we maybe for the next 3 years get those areas which are maybe less supported through the flagship now more strongly connected to the existing projects. And I do think what was said previously to try to establish a mechanism how to add smaller projects to these bigger activities could be an interesting aspect, because there's in many countries there's national efforts which are quite sizable, and these national efforts could maybe be connected to some of the existing bigger projects, yeah, because like a big ion trap quantum computing project or a big semiconductor quantum computing project is so challenging that Europe would probably do better if there was more input from others, maybe not even funded through the flagship project. Yeah, I mean, an example that I frequently mention in this context is if you build a big detector at CERN, yeah, there's just many nations contribute to building that big detector, and they will contribute with their own resources. It's not CERN who distributes the money for people to do these tasks, but people come in with their resources from their home countries and make contributions to this big challenge. And I think that's maybe something that we could think about, whether we could use that kind of mechanism in this European context a little bit.
So we had one question first on the corner.
Yeah, Luigi Occhipinti, University of Cambridge. I wonder whether in defining the long-term plan of quantum algorithms outperforming classical computers, one should consider how the classical computer and hardware and software have enjoyed over the last 40 years an exponential growth, which is nicely traced by the Moore's law and captured by the ITRS. So I wonder whether something similar in terms of road mapping should be put in place for quantum computing technologies and both hardware and software.
Go on the right side and then on the second line. And then.
I'm Oksana Mishina from the University of TU Braunschweig, and I would like to add a comment about the manpower that was raised before, and so that addresses directly the education and training. And here there is something which can be suggested and delivered reasonably in time in the first 3 years, I think, which is shaping up and forming training programs for people who are maybe not having a strong physics and mathematics background, which are engineers, software engineers, and people from users as well. And there is a community of education research who've been working on that, also in the area of quantum physics. And this is something probably exactly to add on the plate in the first 3 years, because training takes time. And if we would need manpower ready for the next launch of the calls, this would be timely to do. Thank you.
Thank you. So we can take 3 further comments. We have the second line here, then Paolo Bianco, and then there. And then we can move, I guess, to the next subtopics.
Good morning. My name is...
Yeah, Philippe Chomaz from CEA. I would like to comment on the fact that we need to look at the whole value chain when we discuss computing. So, of course, the hardware is absolutely necessary, otherwise there is no need to discuss. But if we don't look from the start at the whole problem, this means looking at engineering, looking at all the interfaces, looking at the software, and we also know that at the beginning we will start with noisy type of calculation and not perfect universal computers. And this means that at the same time, what we want to compute may affect the architecture of the computer itself. So in fact, we cannot decouple the computing in hardware and software. Maybe we have to solve a specific problem to look at the hardware itself to optimize compared to the decoherence time. So I think we need to look at the whole value chain, and we need to look at the different projects accepted and look if they are missing something. And I like very much the idea that they could call for help on the specific topic, because not all the consortia will cover everything, and at some point they will miss something. And I think we should, as a community, try to help to progress and to put together and to add what is maybe missing. And I would suggest a call specifically targeted on missing parts in different projects in order to have a complementary vision.
Thank you.
Good morning. My name is Jacob Biamonte from Skulltech, and I just have a few comments. So, as evidenced by the state of software, the European Union was unable to produce a leader in terms of theory. That's why we're here in this situation. In terms of research gaps, for those that didn't get funded, I think that all is not lost. I think now the existence of the flagship can mandate people, for example, approaching even their rectors and asking for a PhD fellowship to maintain a competitive edge. So I think that, keep it positive and think outside of the box. I don't think it's a problem. I think this is an advantage. In terms of what Matonen said, which is very important, how does Europe go about involving those that were, let's say, not part of those funded projects? Well, maintaining and mandating an openness in the workshops and making sure people are able to attend those workshops, I think will be critical. In terms of the software gaps that everyone's talking about, as evidenced by the United States, those will all be filled by startup companies. So don't worry about that. In terms of the gaps in theory, in my opinion, this is an excellent time. So this is really an engineering project. Your nearest neighbor partners will often, let's say, have different mandates on their funding sources. For example, you're talking about China. Solono might be able to involve them to fill those gaps, which are outside of your critical IP strategies. Thank you for your time.
Thanks for the point. Guess we have Paolo Bianco and then after there. Second line here.
Thank you again, Paolo Bianco. Mine is an answer to the question. I agree. What are the challenges? The challenges in the first 3 years are to deliver on the project, and that is going to be a big challenge, meaning not being distracted by the next call, by all the meetings, by being 20 partners in the same consortium or things like that. I think this is a challenge. And the other, and also to keep on benchmarking with what is happening in other, outside the quantum flagship, what is happening in the US, what is happening in China, what is happening in other places. And the other challenge is to tell the community what can we do with 50 qubits. Thank you.
So we have a last comment and then we move on, please.
I would like to address the questions, how can we connect quantum software developers with quantum hardware providers? And let me give you an example how it already works in Canada. University of Toronto created something like Creative Destruction Lab, and this is kind of startup, this is kind of accelerator for startups. And this is a place which doesn't offer millions for spending, but it gives an opportunity to make a network. This is a place where software developers can meet hardware providers, and everyone, especially small startups, are supported by marketing and business analytics, because very often scientists are not very well in selling things. And till now, based on my company, BATE experience, it works quite well. And being a European, what I would like to see is a similar project here in Europe, not in Toronto. Thank you.
Thank you. So Andreas, I propose we move to the next topic, so the medium-term challenges. I don't know if Andreas wants to introduce, we exchange a bit.
So, as I maybe said in the introduction, I think it's possibly not totally easy to fully distinguish between sort of challenges that we have now and that we think that we have in the time which is now and the next 3 years, and a time beyond that. Yeah, I think we probably can't afford to wait on addressing any of those, but I think we would be curious to see what you think are specific ones of these challenges which you think for sure need to be addressed in the next call. Yeah? So do you need a large-scale infrastructure for fabricating integrated circuits for ion traps or superconducting circuits, for example? Could be one of those questions. Is that needed, or are other measures needed that should find their way into the definition of the next work programs?
The same of the previous discussion. I just wanted to try to answer in this second round of it is, let's say, 6 years, and to engage my opinion that most of you know, because it is public. I think we will not need, and it is not recommendable to implement error correction protocols, not even in the 6th year or in the 10th year. Paulo Bianco was asking, we are the end users. For any algorithm that is known, if you try to use error correction, we are going up to 100 million qubits, which will not happen in the lifetime of anybody. So that's what I think, and I think everybody in private can say that. So I think that we will have to continue in the 6th year and 10th year with pragmatism, because to invest 100 qubits, physical qubits, to protect one makes absolutely no sense. Absolutely no sense. Even to say I want 2 entangled logical qubits, I will need then 200, and that's no way. I still believe in quantum computing, but I think that the purely digital has to abandon the error correction path, and we have to be very creative. Also, people were speaking about quantum algorithms. Quantum algorithms have to be developed for real quantum computing platforms, are not for Hilbert space perfect quantum computers that will not exist in the next years. You see, so quantum algorithms have to develop for platforms, not for Hilbert space platforms.
Okay, so that's a view on what the relative importance between error-corrected and non-error-corrected approaches is. And so I think it's an opinion to be shared. But what do you think? So that if I paraphrase it would need to be, okay, we need to focus on non-error corrected applications of our technologies for the time scale 3 to 10 years. So what else to focus on for 3 to 10 years?
Yeah, I wanted to follow on what you say and my point of view as well. I agree with you that for now we have to do what we have in hands, and we are dependent on those constraints. However, from an industry point of view, and maybe more than 10 years actually, we want something that is platform agnostic. We want the quantum software developer to be software developer, and on top of this they use something that is more powerful what they used before. It's mathematicians, etc. They are not quantum physicists. They don't need to understand quantum physics to be good quantum software developer. Again, that will be the long-term future, but this is what we should target from a software engineering point of view. And to complete what was said before, we at some point, and again it's too early, it's still research stage, etc., but we have to target software engineering, quality management, standardization in terms of languages, etc. This is what will come one day. So I know we are long from this, but that's what we have to target. At SAP, if we develop whatever programming on quantum software, this has to be platform agnostic. May work on whatever Europe is developing as a platform accessible to all, but we have also to work on IBM, to work on Atos, whatever is coming on the market. So that's...
Algorithm agnostic.
Let's try not to break up into discussions between two parties, so let's give Winnie the word.
Wim van Hensinger, University of Sussex. I very much respect what Enrique says about small number of qubits, and I think that's absolutely fine, but I think we really also need to focus on actually making technologies a reality which can go to these really large numbers, because there is a lot of doubt that you can really do a lot of the interesting things with a small number of qubits. There's theorists who have looked into that and find that comparing say small number qubits to HPC implementations. There's a lot of reason to believe that the really interesting applications come for a large number of qubits. Now, these not going to just happen if you go from 5 to 15 to 25 to 65 to 110 qubits. Then to get to a billion, as Enrique says, will be a long way. And so what I'd like to say is, what is really important is that we, in the next funding call, we need to have the, at least part of the call has to point to true scalability. And everybody has their own definition of what is scalability, and that is fine, that is nice. But for the next call, what we need is a focus on true scalability, which will eventually take us to billions of qubits.
And do you have an idea what you need for that? Or so what would you ask the EU to help you to do for realizing that scalability?
But maybe I can give you some good practice from the UK, where I'm from. So in the UK, actually, just yesterday, in the budget was announced a call for industry-led projects to the tune of excess of 200 or 300 million pounds. Now, this isn't just being given to quantum technology researchers, but there has to be a significant buy-in of up to 50% of industry, of companies, to achieve that. So I do not believe that academics can produce technology which is capable of going to billions of qubits. That's the same reason why Intel processors are not made in academia, but they're made in very advanced clean room facilities. And I don't think it's feasible either to have some kind of fab facility where somewhat all research groups come to one place and do their own fab. What we need instead is to enable an industry ecosystem capable of then manufacturing devices of this kind. And so my suggestion would be then to enable this kind of style industry, so enabling an ecosystem which allows us that to happen.
So one question there, then after on the back, and then here.
Oh, yeah, thank you. Yeah, I just want to follow up a little bit on Kike's and Winnie's comments. Yeah, I do agree that, we should also look for other types of ways of employing the quantum computers that we might have in the next couple of years or 6 to 10 years. But I also think that we should definitely go for the quantum error correction to really show that it works, I mean, in a full scale, not just in a partial way, like it's been showed now, because that's the only way to get our certainty that there is a way. We want to know whether there is a way to the fully quantum error corrected quantum computing, large scale, or if there is not a way, right? Because if we can find out that in the next 10 years, then we are much wiser, and then we might want to invest more to go eventually to the, millions or hundreds of millions of qubits, which may take then much longer time. So I think that is a very important milestone, even more important than quantum supremacy or quantum advantage with the noisy systems. About the, one of the challenges, I think, and I'm coming back now to my first comment, is that how to involve a larger number of people. I think the challenges, for example, are in what Winnie said about the fabrication scale. So that how to make a sort of a European scale foundry that could provide the chips to the research groups and the developers, and how to deal with the IP related to that.
Okay, so while the microphone goes to the back, we take one question or one comment from the front.
John Morton, still. So just looking at these milestones, I mean, for me, I think reflecting what's been said before, they're not really fit for purpose in terms of conveying the key, it's applications that are really driving this research, and what we see here doesn't really address that. There's a mixture of hardware milestones, some error correction milestones that there's a debate about, something at the end in 10 years about some kind of algorithms. I feel that our top level milestones have to be communicating to whoever's funding this really what this field, what this technology is looking to deliver as a visible milestone. And quantum supremacy at least is an example of an early scale milestone, not one with application. Maybe there's a second one where there's supremacy, at least in a class of algorithm, which has commercial impact. And then the final one where there's a quantum advantage at a scale of a commercially relevant problem is another one. But I feel that things like that, and those working in applications probably have more specific ideas, have to be our top level milestones. And then we can have a parallel set of hardware, a hardware roadmap, hardware milestones that can help enable those. But then we need to think more beyond just qubit number. Obviously, qubit number is not everything. There's fidelity, the scalability that's been talked about. That means that individual platforms need to have a sort of robust, within the different platforms, a robust roadmap for how they plan to scale and have identified the key ingredients to do that. So I think that's perhaps a way to be thinking about these milestones.
Thank you.
Okay, coming back to the point of scalability, because I perhaps can give an idea, because I worked 12 years in industry on semiconductor development, so on the product development side, and what you definitely need for scalability are two issues. You need to work on the, let's say, qubits, on the quality to reduce the overhead. That was mentioned before, because 1 of 100 seems to be not reasonable, but nevertheless you need to be prepared from a system point of view, how a system can look like, which means finally you need very high-end assembly technology. You need somebody who is delivering the chips, that is okay, but first you need somebody who is developing the chips. To deliver it is one point. And there seems to be one clear track in addition. Without highly integrated, I think it will be not possible to get real scalability. You will need a special technology, because all these temperature problems are also not solved, because CMOS is generally working at, let's say, 4 Kelvin, at 100 millikelvin, whatever. But you can never afford the power which is needed for this. And you need also solve this area questions and so on. So you need some, let's say, strong involvement on these engineering capabilities there. Otherwise, you will be not successful. To have a system view and make it down, bottom up to develop real circuits on this.
I just wanted to come back to the point of whether... Introduce yourself. Jonathan Holm, ETH Zurich. I wanted to come back to the point of whether academia can realize these big projects. And I would say there's a stark example. Academia realizes some of the most complex projects that are in the world today. CERN is huge and very complicated, and it does it by specializing a bunch of people but giving them a platform to bring this all into a common place where it works. And that model I think we shouldn't neglect in trying to push towards a quantum computer, because this is a huge challenge. This is really tough, and it's going to take for me more than 10 years to realize anything that I find a particularly strong quantum computer.
So we have a last comment before we move to the next session.
I think one of the challenges is that we identify key components which are necessary for this large-scale quantum computers and make sure that they are available in Europe. So I think this might involve infrastructure. So you mentioned chip design of traps could be photonic integrated circuits. I think that already exists, but it could also be laser diodes, even at different sites. Because otherwise we depend on other countries which might shut down the delivery at some point.
So I guess that your question brings us to the next session, which is precisely scientific and technological resources. So what is needed to succeed, to achieve the goals that we are addressing? So here you find some, so this is the kind of cross-cutting areas. So the idea is to collect idea now and then to discuss this together with all the other platforms to see if there are some ingredients which are not only specific of quantum computing, but of all the pillars. And what you can find here is some first suggestions on what we could address. We have a first question there, first comment.
Martijn Hek, Aarhus University in Denmark. This actually relates a little bit to the previous discussion. It flows nicely into this. So, of course, in parallel to the quantum science community, the quantum technology community, a lot of platforms, be it CMOS, be it photonic integrated circuits, what was already mentioned, has been built up. And of course, since already pointed out by our colleague from Chalmers, it's very hard to do the technology, and I think you have to piggyback on those efforts. But what, in my opinion, would be needed is some kind of, ideally quantitative, roadmap that within those platforms, people know what is needed for this community. So my personal background is photonic integration, so let me stick to that. There are certain requirements that the quantum community, quantum optics community, would need of a photonic integrated circuit. Maybe, maybe not, that is already doable. But if not, it should be developed. But if we don't know what is required, it cannot be developed and it won't be developed. So in short, I think there are platforms and we should piggyback on that. But to be able to converge a quantitative roadmap, in the previous point, components were mentioned. Components, functionalities need to be quantified for that.
Any other thoughts on what? Ah, yeah, okay. So Jonas.
Yes, great. I think to bridge the upper and lower levels of the software stack, we have a great cross-cutting activity that could be there could be a special place for that in the new call, bringing together software, engineering, control, and standards. So to actually make the machine work and to connect the upper layer software and the actual quantum hardware.
There is one question on the second line, on the left side. Here.
Hi, I'm Paraskevas Bakopoulos from Mellanox Technologies. Just a short follow-up from the comment of Martijn on the photonic integration platform. I think a similar approach, we could apply a similar approach also to the knowledge base and the experience that is coming from the HPC point of view. There is a lot of know-how. I think we have to exploit the synergies, to build up the synergies and exploit them. And I would also suggest that we may also even work on our vision in order to somehow, let's say, put the quantum technologies in the overall context of an HPC system or of a fully functional system. So, for example, looking at the long-term challenges that we had in the previous slide. If I remember correctly, I don't know if it's easy to go back to the previous slide. So in the 10 years we are thinking of the demonstration of quantum algorithms to speed up and outperform classical computers. I would even add on top of this, in order to, let's say, to put it in the context of the application, that, let's say, a vision would be to be able to demonstrate a system that integrates classical systems, a classical HPC system with a quantum system, and show that there is actually a benefit to the workloads that are being operated.
So maybe one aspect to steer this a little bit could be: are you missing something that you would like to have, but you don't have it yourself? Yeah, what would you ask somebody to do for you, for your project to deliver? And if you have something available in your company, in your startup, or your lab that you think might be valuable in these other contexts, what is it and how could that help?
Please. Okay, thank you. Paolo Bianco again. Joining together the previous question and this one, I think one of the big challenges in the midterm will be the painful reduction of the potential projects in quantum computing, because I don't think we will have the resources to produce like 7 different technologies or something like that. So at a certain point there needs to be a choice to be done, and that will be painful, and that is going to be a challenge. And the other part about the technological resources in the medium term again will be how actually to put together, how actually to join together all the efforts of what is available in Europe in terms of resources in order to march together towards this final goal.
Could you have something that you would be able to offer or that you would need to make this happen?
I do, and I did it back in the past. Originally, I come from the space business, and I think the way that the European Space Agency is managing missions is the ideal, well, it's not the ideal, but at the moment is one way that exists. And that can be used, of course, you know, it needs to be adapted. Basically, you start with a big number of participants, big numbers of missions, and then you reduce them at the end. At the end, it becomes one, but all the participants are re-involved back into that one in order to actually bring it to success. Thank you.
Robert Jordens, Quartic. I think this ties in a lot what's been just said. So consolidation, I think this is going to happen in the next 10 years. It shouldn't be very painful. I don't think the good ideas should die or should be suppressed at all. But incentives for consolidation, that's going to need to happen. So being able for research groups to retire old systems and incentivizes other companies to supply new systems or ideas or software or electronics. And yeah, this is something that's going to be a challenge, and it also needs to support it and be made least painful.
I would really like to push you a little bit into the direction, ask what is really needed, what can you offer? Yeah? Not only talk about sort of conceptual aspects, what would you do if you could, yeah? But let's talk about what it is that you need. And I could certainly say a few things, and also if you're a company around, yeah, then you should say, okay, what it is that you have to offer, yeah? Why should people be using your products? Why would it be good if it was used across all the platforms? Yeah, because then you could maybe spend more resources on making things that are geared towards quantum technology. So I think it would be really interesting to hear something along those lines.
We have one question here and then another, the last one, sir.
My name is Adam Lewis. I'm from the Commission, from the Joint Research Centre. I would like to strongly support the remark made by Paolo Bianco. This has been completely missing from the discussion up to this point. It is not possible today to know which platform is going to win, or indeed if more than one platform may win. Every time we ask the community, that's the answer we get. Let us do the basic research. We're not ready to make that decision yet. But without that decision, you will lose. Be clear about that. You either have to decide and take the risk, or you will definitely lose.
Yeah, I think it's important. I mean, I see this cross-cutting contributions. I also think it's important to have more standalone directions being supported and being there along the way, and particularly for algorithm design and finding out use cases like Paolo is looking for. And so I think we should think about how to divert the resources in that direction. And also that goes with what Enrique was saying. It goes for basic science, and it goes for basic science touching on how to program these. I call it programming. I'm a computer scientist. How to program these small devices.
Yeah.
We shouldn't.
So if I would turn that around, would you say there is no need for cross-cutting solutions across the different pillars?
No, I'm not saying there's no need for that, but there's also need for future and also current directions that are not cross-cutting, but standalone.
I would see that, but the challenge that we are posed here is to identify aspects that could benefit all the different pillars, and also the basic science pillar, by trying to identify similar challenges and provide solutions to it. I think that's what we are asked for commenting on here, and therefore we need to provide some answers in that direction, or say we don't think that it's necessary.
So, yes, we had one question there waiting. And then I will suggest that we write the last question, because we have 6 minutes last, and then we will have to move to the next pillar.
My name is Ferry Kienberger. I'm from Keysight Technologies, which is a large US company.
What we can offer is, obviously, we can offer fast, reliable electronics. That is important and plays a role here. Based on our experience in the last 10 to 15 research projects we had with our research labs in Europe, is that two things are required. First, we require from the universities particularly to just discuss baby steps, because we want to avoid risks. We don't want to take too much risks as a big company, but still want to be engaged with you. So this is what we require. Don't ask too much from a large company, and find baby steps that we can work on together that have not too high risk, such that it is okay for a company. And then in engineering and control, I think we have the electronic capabilities to make reliable offers to you. But on the other hand, we want also to learn from you in which direction we need to go. So this is good, fostered and collaborated by such meetings like here. Thanks.
Okay, so before to move to the next question, I would like to show you the last question, the last suggestion, which are what does not fit into the application areas, what are the strength and weakness of the flagship, and what is the added value. But we have left only 5 minutes, because then we have to respect the timing, and who's going to attend the quantum simulation will have to move to the other rooms. So I guess now we had one comment there.
Well, the weakness obviously is that there's not enough money. Everybody wants to do everything. But I'm a little bit coming back to that, previous slide, and I would like to point out that the software is very important. Now, I'm not talking about, the higher level software, but actually the software we use to run the equipment to control these devices. So you could call it firmware as well. I think that is a critical part of the mission. And we could, for example, in my lab, we would be happy to use a unified software and to develop that together with the other projects. We could convert fully to that, and this way we would benefit from the flagship project, and we would at the same time give something. And this would, there are a couple of open source softwares around, but this, we should just make a strategic choice that which software we choose, and then we would convert into that, and we would also give all the subroutines that have been developed in each group, which have not been published. A lot of people use some open source software, but then they build something on top of it that they don't put to GitHub. But this should be done, that everybody can really then, as a community, we can decide what is the best way to do measurement, for example, what is the best way to do control. And then, these routines would be automatically updated, and people could take them into use very quickly.
I'd just like to agree with that. I think that we're here for quantum computing, and the most important thing is that we identify the resources for quantum computing. And if there's added benefit outside, then that's great. But examples around control software, the control instrumentation, FPGAs, AWGs, all this other room temperature electronics, there's a lot of commonality across that, and those are key resources. Other areas like in the cryogenic platforms, cryoelectronics for controlling qubits closer to the quantum qubit layer would be important. Obviously, fabrication has come up a lot. I think these are different resources that are core to quantum computing and maybe have applications outside, but I think the first priority is working out what we need to develop computing.
So maybe one thing that I would encourage you to do, the time is running out, is to just mention aspects that we haven't touched on. I thought that, for example, the IP question was very, very important. We've not really talked about it. Are there any aspects that are similar that we should keep in mind, maybe for further discussion in the coffee breaks and on other occasions? Just try to be brief, yeah.
On the previous slide, there was a question of how can we help to achieve goals. And what I would like to suggest is to change with universities and with students. I would like to adjust programs and create new course about quantum processing, about quantum information, to make young people available of this technology and to be prepared to find themselves on the market with employees. Thank you.
Oh, hi. I'm Radu Nicioiu, QCN for Romania. So regarding the cross-cutting, I think education is one of the issues which has been raised before by Oksana, but not strengthened enough. Of course, we need applications, as Paolo said, and we need quantum software for that, we need quantum hardware for that, but we also need to educate people. And I think platforms like IBM Quantum Experience or Rigetti are important, because without software engineers, you cannot push applications forward. And let's not forget that the whole IT industry was based around computer science departments in Silicon Valley. So we need, it's like growing a very strong tree without strong roots.
So I'm not sure how realistic this is, but something where I think a European program could contribute would be to define a common set of performance parameters for devices, so that I can easily compare someone's device to someone else's device without having to read 10 papers.
Let's take a very quick last one and then we wrap up.
I think one thing that's missing is to identify not the things that are limiting us today, but the things that might limit us in 5 years' time, and hit those technology points. So for ion traps, that might be very high quality coatings in the ultraviolet. They just don't exist, there's no incentive to build them, and there's one guy in Boulder who makes high quality coatings in the world, full stop. So that's a problem upcoming we should try and address.
Okay, so I guess we're out of time at this stage. So I'd like to thank all of you for your active contributions and to this session. I'd like to thank the two other moderators of this session for their help on it. What we'll do is we'll summarize your input, and there will be a session at later today where the summaries of the other sessions will also be given. And then if you think something was missing, feel free to provide and write an email to any of us, and we'll put it in this document. Okay, so thank you for your participation, and see you for the next session.
Thank you.